Morning, everybody. My name is Rodolfo Jarano. I'm based in Houston, Texas, and I am a solutions engineer, sales engineer, pre-sales engineer, whatever you want to call it. I have many titles. We're going to talk about what we do in the space of containers and what do we offer within the SUSE Linux Enterprise server for high-performance computing. Okay, so I'm going to start with some basics. Everybody knows what a container is, I suppose, kinda. So I won't go too much into this, but yeah, as you will know, it's an image bundled with your operating system, and you bundle your applications, all of your requirements for your app. It is immutable, so if you actually patch an image, it's a new version of it is created. Okay, it is very portable. In theory, you can move anywhere you have a Linux kernel running. You can run your container. Okay. So traditionally, what we've done in the past is have your VMs and a guest OS and your apps, but everything's been kind of siloed. Where we're trying to go and get at is to the containers, where everything is going to be smaller chunks, easier to manage, easier to update, easier to go to market for you and your customers. So yeah, it's easier for the developers to just basically package everything within this image and deploy it. It can be the same code in dev all the way through to production. Okay. And as I mentioned before, they are portable, so you can move them from your bare metal systems to the cloud, to VMs, wherever you need them. Okay. So what do we offer in the container space? So there's two things I'm going to talk about today. The first one is Singularity, and there is a talk, by the way, right after mine, where a Singularity engineer will come and do a deeper dive. I will basically just go through telling you what it is, the key features, and how to use it if you're running SUSE Linux Enterprise Server. So I guess that would be a question. Raise of hands, who is currently using SUSE Linux Enterprise? All right. Hey, I'm not surprised. Cool. So yes, Singularity is the first one that I'm gonna be talking about. Am I blocking your view, sir? Sorry. So yeah, basically, for me, how it's resumed is that last sentence. It allows you to run your containers with untrusted users in a trusted way, basically. So in HPC, it's all about security and how you run your containers. So again, the key features, they use something called SquashFS image. It's called a SIF image. You don't have a service per se in the container. It's an application, and then you can, with very simple way of just using your existing Docker images or containers, you can just deploy them as a Singularity image or container. These are basically the steps. You can get and install Singularity from either the Open Build service if you're familiar with it, or you can add the Package Hub repository to your operating system, and you can get Singularity that way. Okay. Once you have that installed, you can get. In my case, I'm just pulling a generic container, and then you basically just run it with the command Singularity run my container, and that's basically it. Okay. So quite simple. There's no change that you need to do to your existing container as it is. Singularity has plugins or integration with GPU, so you can make use of your GPU as well. You can deploy and utilize Singularity within Kubernetes as well, so there's a plugin for that, as well as using a containerized version of Slurm or Univa or adaptive computing for your workload management. Okay, like I mentioned before, the key is security when you're running and talking about HPC containers. Okay. The second one that I'll talk about is called Charlie Cloud, and this is a little bit less known than Singularity. Singularity, the last couple of years, has been the one that people talk about in general. But Charlie Cloud basically uses a different way of securing. So it does not give you privileged operations, what it does is it utilizes the user namespaces in order to run the containers in a more secure way. Okay, so again, the packages are available within OBS. Charlie Cloud does not require Docker, and it will does not run a Docker container image directly. There is a way of converting your Docker container into a Charlie Cloud. So there's that command ch docker to tar. So that will allow you to convert and run your existing Docker containers within Charlie Cloud. So again, how do we deploy it? It's basically available within the Open Build service. You install it. You would need to get your Docker image and run that command that I mentioned in order for it to be converted into a Charlie Cloud container. Then that will create this is the resulting file. You uncompress that tarball, and then you can simply run Charlie run your container, and you're ready to roll. Okay. Where does SUSE HPC fit? Okay. So a little bit of background about the product itself, SUSE Linux Enterprise Server for HPC. We have an HPC module within that distribution that packages a lot of the common tools that are used in the HPC world. Why is this important? Because tools like Slurm, for example, if you want to get support, I actually have a customer that wanted support for Slurm, so they were in contact with them, but then they called us to get support for the OS because we provide Slurm within the HPC module as part of the distribution. We actually support the OS as well as the tooling. Okay, so we provide support for Slurm at that point as well. So we support not only x86 but also ARM architecture. We actually have in the back a pretty cool demo of AI and machine learning utilizing NVIDIA GPUs running on ARM processors. So that be sure to check that out. It's in the back. We work with a lot of partners, and this is our core, right? We surround ourselves by great relationships, great partners in the hardware side, and the software side, and the cloud service provider as well. We're actively investing. If you go to the back there, you'll meet, I think it's 2 of our developers that came all the way from Germany to visit us. So we're growing that team, we're expanding, we're actively working on new projects and adding new tools to the HPC module that I mentioned before as well. And it's very competitively priced. So also if you're interested, be sure to talk to one of our sales guys in the back of the room there, because it's very competitively priced. So this is basically the whole gamma of everything that we support and or provide as packages, all the different communities that we're part of, like OpenACC for the graphics, the GPU support, as well as a lot of ARM processors, a lot of different relationships there, and deployments already, as in the case of those universities there. And like I mentioned in the HPC module, this is just a snippet of all the packages that we provide and the tooling that's used within HPC. Rise, just keeping with the theme of the rise of the chameleon, rise of high performance AI. So there is a huge pull in this direction where we're doing high performance AI in a containerized way, which allows smaller files for hyperscaling environments. So traditional ways of doing AI are being doing in a containerized fashion as well, and this all ties in with what we were talking about earlier. So again, which communities are we a part of? Key communities. Of course, Ceph for storage that we have a product for. I see one there that I probably should have taken out now, but we'll go on. OpenACC, like I mentioned, is very important for us, and a big push in that community to get the GPUs supported and running in our operating system. Key capabilities, again, these are part of all the tooling that we either provide or working with to get supported versions for you to consume. Key ISVs. All of these are vendors that we partner with, so that you can make use of their products and they are certified in our operating system for you to use. I have some additional resources there if you guys are interested in checking out what we offer and all of our different documentation sites. You can go ahead and take a picture of that. And with that, I blew by that presentation. So any questions at this point?